Welcome, everybody. Niels is going to show off some of the work that he's been doing on refactoring the Flytekit to sort of more cleanly separate the remote interfaces from the rest of the interfaces. So I'm going to take that, let him take it away.
Well, thanks, George. Morning, everyone. My name is Niels. I'm, I guess, fairly recent addition to the team, but maybe not so much anymore. I don't know. But yeah, can everyone see my screen? Just cool. Just making sure. And if I do this, does that mess anything up? That's just full screen. Okay, cool. Great. So yeah, I've been doing some work on the Flytekit code base, and the thing I'll present on today is the new remote package. And like the main thing, as you can see here, is it's called FlyteRemote, and it's sort of, you can think of it as a client to any kind of Flyte backend. And it does use the synchronous client that some of you might be familiar with, but it kind of repackages it a little bit more nicely. So right, interacting with the Flyte backend made easy. So for anyone who's curious, the slides for this, I'm using HackMD, which is, I'm just kind of experimenting with not using PowerPoint or Google Slides, and just making presentations with Markdown, which is pretty cool. So the outline for this presentation is I'll give you a little bit of motivation behind this work, give you a little before and after snapshot of how things used to look and how they look moving forward, the design of the remote package, certain decisions we made, and we'll continue to make as we iterate on this, which actually FlyteRemote is kind of in beta, so that's a little warning there. I'll show you a quick demo of the new functionality and potential next steps for improving things. So I like to frame things in terms of user stories. So this one is, as a workflow author, I want to fetch, register, execute, and inspect Flyte entities in an interactive environment. Although not exclusively an interactive environment, you could potentially use this sort of in a script to orchestrate different things. But the primary use case is if you're in a REPL or a Jupyter notebook or something, and you want to improve your ability to debug tasks, workflows, and launch plans. This new packaging might suit you better. And as I said, we'll improve this as we go. So just as a reminder, currently there are two ways of interacting with the Flyte backend besides the console, obviously, but so programmatic interaction, I suppose. So there are a bunch of command line interfaces, FlyteCTL being the newest, shiniest one, shiny one. And in the past, I guess these currently exist. So PyFlyte and FlyteCLI also offers some ways of interacting, like registering tasks and workflows and stuff. And the second way is with the Python SDK, i.e. Flytekit. And I'll show this a little bit later, but there has been, we have supported this functionality for some time, I think. But as I said, this is sort of like a repackaging of things to make things a little bit more mentally ergonomic. So if we consider just one use case, this is probably kind of like the majority use case, although I have no numbers to back this up, but I'm guessing this kind of workflow of fetching this kind of task, oh gosh, everything is overloaded. This guy, if I want to do something, right, and like fetching a workflow and executing it, I want to be able to sync the state of the workflow execution with whatever is in the remote backend, and I want to wait till it's complete and look at the outputs or look at the errors that resulted. So before you would do something like this in Flytekit, there are the obligatory imports. You would use this SDK workflow class to fetch the workflow, pointing to whatever project, domain, name, and version of the workflow you want. You can create a launch plan out of it if you want to execute that workflow. I mean, I think maybe Yi or someone can correct me if I'm wrong, but I think this was the way to execute said workflow before with the old SDK star stuff. So you would then launch an execution with this launch with literals method, and you'd have to provide a literal map of inputs to feed the launch plan, and then you would call this wait for completion method, and then you would be able to print the outputs at that point. So this was pre 0.21.2, 21.2. So now after, the code doesn't look super different, but I'll kind of highlight the main differences in a second. But you can see here that I'm doing one import of this FlyteRemote class, and I'm instantiating this object from configuration. So this initializes a remote object with a default project and a default domain. And there's a bunch of stuff that happens underneath to pull in the config files and environment variables. And that populates a bunch of things under the hood that are necessary to like actually make remote calls. Included in this would be like the URL of the backend, the port and stuff. So once you have a remote object, you can fetch it. You can fetch a workflow by naming it, and you could provide a version, but if you don't provide a version, it'll just grab whatever the latest version is. And you can then execute this workflow. This is now a Flyte workflow object. And it represents the state of whatever you've registered in your either sandbox or your remote deployment. And you can give it Python values instead of like having to import literal, the whole literal package thing back in the before picture. And you can see that I'm adding this wait equals true argument in the execute method, and that will wait synchronously for the execution to complete before returning the workflow execution. And then you can print the outputs. So this is the before after snapshot. I'll get into the design of why we decided to centralize the object or the class that makes all the network calls, then basically all the other kind of Flyte entities, as I'll call them, so tasks, workflows, launch plans, and others. Those are basically data containers that you can access the inputs and outputs and like various other things. So they themselves don't make any calls over the network. So the goal for the design is to just streamline what it's like to interact with the Flyte backend. And so before, with these SDK star classes, basically each Flyte entity implements its own methods, as I said before, that makes network calls, where each class has some overlapping and some distinct behavior, right? So like workflows, you would fetch it, you could register, serialize it, and create launch plans. And then the resulting launch plan is the thing you can execute. And for tasks, you can do a similar thing, but kind of like the method names were slightly different. Of course, we could have cleaned this up in another way. We could have like created kind of maybe a parent class that implements these kind of methods in a more consistent way. But the direction we went with is to centralize things so that we're kind of separating concerns in the sense that the remote object now handles all network calls, and any Flyte entity you get from it, or any Flyte entity you get from it or feed into one of these methods are basically just data containers. So as you can see here, there are basically 5 method types in FlyteRemote. There's this fetch method for task, workflow, and launch plan. You can call remote.register to register local flight task, workflows, and launch plans, execute them. This will return an execution object that you can then sync. So you can call sync to just get whatever the most up-to-date state is in the remote backend. And you can call wait to wait for the execution to complete synchronously. So one other thing, this is not like super important, but just to call out that these flight classes take advantage of single dispatch method. So we can have the same name and apply different logic or implement different logic for the various different flight entities. So in this case, it's a single method that can take in, flight tasks, workflows, or launch plans, and it'll know what to do with them. And finally, as I mentioned before, you can inspect these objects more easily. Like the properties are fairly intuitive, I want to say. So you can print out, and I'll show you this in the demo, but workflow.interface will give you the interface, like inputs and outputs of the workflow. You can do the same for tasks. And then for executions, they have this inputs and outputs property. Okay, so hopefully this doesn't fail miserably, as demos sometimes do. Cool, so I have a Jupyter notebook here. There's some like background stuff. So I have a Flyte sandbox running locally. This environment has access to some environment variables that I've set beforehand. Don't worry about it too much. Like for example, that it points to localhost 381. So we're just making sure this remote can actually connect to my local sandbox. So this remote object, we can look into it if anyone has any questions, but I'll just run through this demo in order. So the first use case here for fetching and executing a workflow, I'm calling fetch workflow to do that. And I'll just remind you that this is, one of our beloved flight snacks examples, a really simple one that looks kind of like this. Oops, that's the wrong one. Yeah. So this is basic workflow.py. It has my workflow, which uses 2 tasks, and they're fairly simple. You can kind of just read them here. But when I fetch it, this is now a Flyte workflow type, and it exposes a bunch of stuff that, okay. Yeah, so it gives you can inspect it and see what the ID is, what the interface is. So as I mentioned before, you can call that interface here. And let's go ahead and execute it now. So I have let's move my screen around. I also have the console here available to us. So let me just find the basic workflow. And I'm going to execute it and wait for it to complete, giving 10 and foobar as inputs. So now you can see it's running. Jupyter Notebook is still waiting for the output. Should be done in a few seconds. But I've pre-run this notebook. And one thing you can do with this is also iterate through the node executions. So you have access to all the different node executions of your workflow. So this is the node execution for task 0. Yeah, this is lagging a little bit. Okay. yeah, so you have the node execution for task 0. You can print the inputs and outputs of that specific one, and then same goes for task number 1. You can do the same. You can actually execute local workflows with a big caveat that this is more of like a convenience thing where if I can import my workflow here. So I've added the Flyte's Next cookbook to my Python path. And so now I can import it here. I can actually execute the workflow function directly with the caveat that I have to know the version that I want to execute beforehand. So this isn't actually doing anything super fancy. It's just more for convenience if you actually have your workflow, your @workflow decorated function handy in your environment. So this will do the same thing, and it'll. I'm here. I'm just printing the inputs and outputs. You can basically, I'll kind of breeze through these, but this is the same thing for tasks. I can fetch a task, look at its interface, and execute it as a single task execution. So should be here, and you see that it's running. There's actually a terminate method here as well, so I can terminate it from my remote, like my interactive environment. Yeah, I have to kind of time this well because wait a few seconds and then terminate it. It's running. And I terminate it, and then this should go into the abort state at some point. There you go. You can do the same thing with local tasks. So if I have the local task @task decorated function, I can execute that. This is something we haven't discussed too much, but it would be nice to be able to actually register tasks from this using the remote object, but not sure yet. I'll skip this launch plans thing because it's very similar to the workflows. So you can do the same exact thing with fetching launch plans, executing them. The last bit I did want to get to before going back to these slides is the whole limitation around not being able to register and execute local tasks and workflows or local tasks doesn't apply to task template tasks. So you can, for example, define a SQLite 3 task here as an example of a task template task. And so here I'm using this one SQLite table and doing like a super simple query on it. So let's define this interactive SQL task and you can register it. Just to make sure, I'll give it a name here. So my new version. And if we hop on over to the console, we can see that there's this basic querying task with my new version here. That's the latest version. And let's go ahead and execute that with a limit of 10. So this will give us the first 10 rows of this table. And this time I'll give weight equals false, just to prove to you that you can't, it'll complain. So here I'm calling sync, so I'm getting the latest state of this execution. Eventually it'll give me the output. We can also prove to ourselves that this is running. Oh, I guess it succeeded. Yes, and so it's completed with this output. Another way you could do it, like, so this is not sure how often this case will come up, but you could execute a task and not wait for it synchronously, do some stuff, and then call the remote.wait on it to synchronously wait for the execution to complete. So here I'll do another workflow execution that happened really quickly. And then I'm just unpacking it here to prove to you that we have a data frame of results in this query. Okay. So in summary, FlyteRemote provides a centralized API for interacting with the remote backend. This is sort of, so on the top here are the methods, the main methods of FlyteRemote, and each of the different Flyte entities that it can operate on, and can kind of support for it. So check means it's supported and tested. The questioning emoji is whether we want to support the method for the corresponding entity at all. And then these gray circles are kind of partially supported Flyte entities and method combinations. So for example, for Python tasks, only task templates can be registered and executed. For the rest of the local Flyte entities, you kind of it's just a pointer to whatever the remote backend workflow or task or launch plan is. And so, for potential next steps, it would be pretty cool to be able to fast register local tasks and workflows. I'm not sure if this is possible, so it may not be. And then right now, you can't really re-register a remote Flyte entity under the new project and domain, so that might be a useful thing to have. And as always, yeah, if people start using this and have ideas, we welcome any of those.
I have a question, Niels. The very first line that sort of initializes the remote object, does that ensure connectivity? This thing that says flight from config. Yeah, remote equals from config. Does it actually validate the connection, or that it can connect, or do we have to do an operation to do that? And second question, sorry, you can answer both. Does it? What happens if you have authentication enabled on your server?
So for the first one, it doesn't actually check. That would be probably a good thing to do. And for the second question, I think there's some so yeah. Sorry, can you repeat it?
Sorry, yeah. So if you have authentication on your Flyte backend server, and you try to do any of these operations, will it go through the authentication flow and maybe prompt you with the browser to authenticate? How does that work fine with this interaction, or does it require any extra setup from the client side? Also, I guess for Jupyter, I'm not sure how does that work if it tries to pop up a browser to authenticate. Not sure if any of that is tested. That's okay too. It just is.
Yeah, I'll have to get back on you on that, because I remember testing this on demo.nuclead at some point, but I'm not sure if that required authentication. It does, right?
It did, yeah.
Yeah.
Okay.
Yeah.
That's good. Cool. That's pretty cool. The one part I think you clarified later on. If you import a Python workflow and you use that in execute, the only information it extracts from that is the ID, right? It doesn't
basically.
the code or anything. Okay.
Yep.
Hi, Niels, I had one question. So when you execute a workflow, isn't for most users, once they go through the docs, it might be a little counterintuitive that we actually execute launch plans and not workflows. So how, what's the mental thought process behind that?
Behind directly executing workflows?
Yeah, because what's actually, if I have to guess, what's happening is actually it's executing the default launch plan for the
yes.
workflow. but because we show a workflow as an example, maybe it might confuse some folks. Is that right? And then how do you execute launch plans? They're named launch plans.
You can, I guess you can register launch plans via the other kind of like the longer, or I guess the canonical way of doing it with like Flyte and all of that. And then you can fetch launch plans with the remote here. So yeah, in this case, I'm just fetching the default launch plan, which is exactly the name of the workflow. But if you had registered another launch plan here, you could provide that name, and it would return this the corresponding launch plan.
Yeah, I think I missed the method name here. It's fetch launch plan, because somewhere else it was fetch workflow. At least that's what I thought.
Yep.
Maybe the left-hand side you called workflow in the other example in your slide.
Oh, yeah, maybe there was a mistake there. But yeah, I mean, I think our thinking behind this was that, and by we, I mean Yi and myself, is that like it's sort of a convenience to be able to mentally not have to think about launch plans when you want to execute a workflow. But under the hood, it is fetching the default launch plan.
Yeah. I think we should add a method to create a launch plan too, because launch plan creation is just like register. I mean, it's very lightweight operation.
Yeah, agreed.
But yeah, this is awesome. Like, I think it looks extremely clean. I actually think it's possible to do registration for all task types through Jupyter Notebook. But yeah, in a future iteration, we'll do a demo one day.
And this is all in the already released, Niels?
Yes, that's right. I need to write some examples on Flyte snacks, but there should be documentation on the Flytekit API reference.
One question: is it possible to like search or just list workflows and tasks similar to like the flytectl get command? I think it is. Does remote allow it, something like this, or do you have to know the workflow ID in advance?
No, that's a great idea. Yeah, I mean, like remote. I don't know why my Jupyter thing is right. So like, it's a matter of like exposing a method that just makes it super easy. But yes, that would be. I think that's a good idea. But it currently does not.
Okay.
We figured, so we exposed this client thing, which is the synchronous Flyte client, for any enterprising users who want access to that. But yeah, I think being able to list it directly would be great.
And another question, I think this is more for Ketan, maybe, because you just said it might be possible to actually register all kinds of tasks. So how is it possible if you need to build a Docker image? Sorry, I think you're muted, or is it just me?
Yeah, no, it's I was muted. Yeah, so I think the reality is the reason why you cannot register is to build a Docker container. Well, fast registration goes around it, right?
Okay.
And so the other reason why we cannot really execute is because in Jupyter notebooks are not like Python modules where you can load them and just like load that one function. Though it's really possible with magics, in Jupyter notebooks. So if you would do some sort of stuff, you should be able to essentially load a task and run it and use fast registration to kind of serialize the notebook itself and send it over to the server. But This is theoretical in my head. Right out.
Okay, cool, interesting.
Yeah, but after that point, like, and then this circumvents the fact that you have to use papermill or you have to convert the notebook to a Python module or use pickle. Either all three of them are a little not great at they have various problems in different scenarios. So I think it's possible, but we'll have to write. It won't be natively possible in Jupyter Notebook. I think we'll have to add some like matchings or something to it. Else? Yeah, I think this was thank you, Niels, for doing this, because this was one of the most requested features the last 2 months. Almost everybody's like, oh, where is that way? Like, we had this old thing. How do I do this? And so thank you. Niels really, like, did an awesome, fantastic job.